Hello to all of you, dear friends who are interested in learning the Python programming language. Thank you for being with me in another educational video of this widely used programming language. In this part, we want to learn working with Unicode characters in regular expressions. By default, the RE module has a basic knowledge of some Unicode characters, like the function it has with \d. But what happens if these numbers are in another language, for example, Persian? Let's import the RE module. Let's define a variable number, re.compile. Let's have pattern actually, /d plus. Okay. And now let's see if there is any match between, for example, these. It returns a match object and works with this pattern. And now let's check if a number that match with these characters. I want to import the Unicodes of the Unicodes which are corresponding with numbers 1, 2, 3, 4, 5 in Persian writing style, actually in Persian language. Let's have again U06F2, again U06F3, again U06F4, again U06F5. Okay, you can see that there is no matching. Okay, so these regular expressions are familiar with some character classes. We usually normalize in mapping and searching, but the point that you should be careful about is the modes where you work with a series of special cases. Look for character encoding. Let's see, character encoding. Okay. Let's define another pattern in this opportunity, in this time actually. Compile a /u00dfcd, and we want to say ignore case. We want to consider this flag too. Let's check these character encodings in the Wikipedia page in order to see some special characters. Here we want something like this. For example, we want to have a B, C, D, but instead of B, we want this Latin sharp S, which Unicode is U00DF. We consider it here U00DF and CD, which we wanted. Let's run this cell. Okay. Let's show the representation of this U00DF. Okay, you can see that this is the representation of a sharp S, and we want to, if we have a variable S as A and this character here and C and D, okay, Now let's check if this pattern is consistent with this string or not. Actually, we want to say if it matches to our pattern or not. Match the S. You can see that there is this matching here. The point here is case folding. Case folding is the process of converting all characters into the same case, either small case or capital case. Let's see if this matching with S dot upper. If the cases are upper, you can see that there is no matching. This time there is no match. The point is in this Unicode. Let's see what is the S upper. The uppercase format of this S is this. You can see that it prints 2S. You can see that instead of a sharp S, two large S, two capital S actually have been returned. So for this reason, we have to be careful about this case folding and the effect that it has on our string. In general, combining a Unicode with regular expressions is very interesting and widely used and sometimes very complicated. In such cases, for more professional processing of regular expressions and Unicodes, there is another module called regx. You can download it and install it and use it. Actually, this module is a very good choice for working with folding. I'm not teaching this module here, but if you need more professional processing or if you are interested, you can install this module and use its features. Okay, then next discussion. Let's go on markdown mode, insert a square, consider a space, and write the topic. Removing unwanted characters from strings. Suppose you receive a series of text inputs and you want to delete dash lines, for example, or white spaces, for example. We use strip for this purpose. We use L strip to remove characters from the left side and R strip to remove them from the right side. This method removes the white spaces by default. For example, if you have another S, like for example something like this. Okay, and apply this S strip on it. You can see that it removes the white spaces from the left and right, both sides actually. If you apply L strip, it just remove the white spaces which were placed in the left side of your string, and on the other hand, if you apply R strip, you can see that the process is reversed and the white spaces available on the right side of your strings are removed in the output. Now consider if, for example, you have another S like this, for example, and some stars here. Now if you let me name it S1 and apply the S strip method on it without an input argument, you can see that since there were no white spaces on the left side and right side of your string and nothing were removed here, it just removes the white spaces by default, and there is no white spaces in the left or right sides to be removed. But if you if you consider dash dash line as an input argument, you can see that the dash lines on the left sides of your strings are removed, and also if you consider a star as an input argument, you can see that they are removed in the output. Now you can combine two with each other. Okay, and you have the desired output. This method has nothing to do with the middle of your phrase and does not remove a character from the middle. Let's again consider S2 as some white spaces and consider as a laluha. Okay, now let's again apply the S strip without any input argument I need. Okay, you can use replace to remove the character from the middle of the strings. For example, if you apply this S to replace, we want to replace a white space with nothing. Okay, another method that can be used among the methods in the RE module is sub. Let's again import RE to have them all packaged together. Sub, we want to replace the white space which corresponds with \s in among regular expressions with nothing together, and we want to apply these changes on S2 S strings. Okay, you can see that the white space between Azal and the Laluha two L's are removed. Okay, here we use a plus instead of star because we don't want a white space to be added to the text if there is no one. Let's go to another discussion. The next discussion is refining the text. This title is very general. We have done a lot of work on texts so far, but in this part we want to use newer methods. Okay, we want to have a Python in some other formats. For example, let's check this page of Wikipedia, which contains a list of Unicode characters. Okay. For example, let me these could be okay. These are the case. For example, we wanted this one. We want this one instead of normal Y, or for example, okay, I use this page in order to package these Unicodes together. Let's try them. For example, if we have, consider P backslash U00FD backslash U0 the same age, and U00F6 backslash U00F1. Okay, what is the problem? This is a U00F6. The problem is about O, Python O. Let me find another O which is not like the normal form, a Latin O, a bit different. For example, I want this U00F6. What is the problem here? Oh, okay, I forgot to consider a U here. Okay, now we want to consider an S which is the same S string. Okay, and we want to define S1. For example, we want to have this backslash T is backslash F great backslash R backslash N. Backslash R is for going to the beginning of the line. Backslash T pushes a tab forward, and the backslash N is using for considering a new line. We can show this as fun. Okay. Here we can use str.translate. In fact, let's use a dictionary including keys and values. Let's define the dictionary map backslash T nothing. Let's at first consider it like this. For example, backslash T nothing backslash F nothing backslash R. This time we want to consider none. Okay, let's try it at first. Let's define a T1 which is S1 dot translate. The tool for this translation is this map1, the dictionary which we just defined actually. You can see that what we wanted was not done because this backslash T inside the expression has a different meaning. We have to find this meaning from the ASCII code. For this purpose, we must use ORD. We need to have this dictionary, but make a little change on it. Okay, and again we do the same. Again we show this T1. Okay, One point is that there is no other line in this example, so there is no need to keep this \r character here, hence we mapped it into none. You can see that we reached the desired output here. In cases where we work with control expressions such as \t, \r, we should take help from ORD. It means that Python understands that the value of tab, be it ORD, applying into \t. Now this mapping idea can be taken one step further. Let's import the Unicode data and also import sys. Let's use the combining one of the methods in Unicode data, combining. Let's see what will happen if the input argument be 10. You can see that the input of combining method should be a Unicode character, and this is the reason of this error. So we again do it, for example, with A. Okay, let's do it again, for example, with U00FD. You can see that this is again a 0. What about the result if the input argument is this one? Remember that U0303 is corresponding with a tilde mark. And Spanish character. For all cases where your Unicode actually refers to a symbol, for example, a tilde or two dots above O that refer to letter sounds, this method returns a non-zero value. You can create a map for all of these and delete them in this way. Let's become familiar with dict dot from keys. We gave it a series of keys and it corresponds to none by default. Let's see sys dot max Unicode. Okay, now if we want to have an access to the character, we need to use the CHR. Let's see sys.max Unicode. Okay, the same output. Decimal value of U0303, which is corresponding with tilde character, is 771. Let's see what is the output of applying CHR function method on it. Actually, we can see the output is correct. So if we want to access the characters of CHR, sys.max Unicode returns a number. Let's use it. Have this Unicode dot combining and apply it on, for example, CHR of for example 97, you can see that this is a 0, but if we apply it on the CHR of 771, you can see that this is 230, which is a non-zero value. This behavior is our desired one here. Okay, let's define a CMap like this. Dict dot from keys. The input argument is C for Cin range of sys dot max Unicode. If Unicode data dot combining with an input argument of a CHR of this C. Okay, that is the result of this combining is false for wide range. Let's now have a representation of this CMap. Okay, you can see. Okay, a wide range of them is none. Now let's show the T1. Okay, we want to remove these sounds from this string, and now if we give n tilde to this code, it will return a 0. Decimal of n tilde is 241. Let's have CHR of this. You can see that this is 0. So it is better to separate these sounds from the letters so as not to face problems for processing. Let's have a T1n as a Unicode data dot normalize and NFD and a T1. Let's show this T1n. Okay, now these sounds and letters are separated. Let's apply the translate on it. This is how translate is used and where general mappings can be made. There is another simpler method for very simple cases. You first normalize your expression. Let's again show this T1. Now let's have an T1. Let's have an T1 norm, which is equal to Unicode data dot normalize on NFD and T1. Here you can use the encode method on the strings themselves at T1 underline norm dot encode on ASCII codes. Actually, it has error because the interpreter does not know some of these characters, so we consider another input called ignore. Okay, here we consider ignore. Okay. Now let's again decode it. If we do not normalize the expression, some characters will be removed. Let's try it at T1 dot encode with the ASCII and ignore. Okay, you can see what happened. Now suppose this time we want to do this mapping to convert numbers from another language, for example Persian to English. I will discuss this topic in the end of the season exercises, which will be our last training video. A very important issue is performance. For example, in simple substitutions, it is better to use str.replace, or for example, instead of using translate, you can define a function similar to c white space, which I am going to define here. White space. Okay, let's define s.replace. Okay, let's start replace and okay, and we want to have same, but this should be T and this should be F. Actually we want to have this as none. Okay, and now we want to call this defined function with the input argument s1. Okay, this cannot be none, and we can do something like this. Now you can compare the runtime of these codes by putting %meet before these codes. If you print it, okay, this is not. Oh, maybe our S is changed, has changed here. Our S1, where is our S1? This is our S, and this is our S1. Let's consider, okay, let's again define this S1. This is the S1 and we want to use it. Okay, actually let's here return S1. Okay, this is okay. Let's put the %time it. Okay, double percent. Okay. It is run in 3.5 microseconds, and it is computed by running 100,000 loops. Okay. Let's again. Let's see how can this T1 do. This is the T1 and this is the mapping. Now let's have another cell here and percent time it. Using the simple function took 3.8 microseconds and this high level method take 5.99 microseconds. You can see that in simple examples it is better to use simpler methods. In more complex calculations it is better to use more advanced methods. It is not possible to provide a single solution to solve all of the problems that arise during programming. Rather, the best method should be used according to the conditions. Determining the best method is possible only with a lot of practice. We applied all the points we said on the texts because our focus is on the texts, but this method can also be applied on the bytes. Thank you for joining me on another Python programming language tutorial video. Stay tuned for valuable tips in the remaining few videos of this tutorial. Have a nice day.